Good morning. Welcome to today's lecture, Basics of Finite Element Methods. And the agenda for the today's topic are Introduction, Finite Element Methods, and Advantages and Disadvantages of Finite Element Methods. Introduction. The production of any mission component related to any field of engineering like aeronautical, mechanical, civil, electronics, etc. depends on works of mostly two departments such as design and production. As per the requirements, the component is designed, and based on the design parameters, the component is manufactured by a suitable method. When designing a component, many factors like type of loading, size, and shape of the component, purpose of usage, place of applications, environmental conditions, quantity required, appearance, etc., are being carefully analyzed by a design engineer. While dealing with the type of loading, the resulting parameters like nature of stress, strain, displacement, vibrations, etc., must be carefully analyzed and considered. Also, due to the operating and surrounding temperatures, the parameters like heat transfer, temperature distribution may also be analyzed. If the situation and the other factors, as mentioned above, like the type of loading, etc., are simpler, then the analyzing method will be easy for the entire component and the solution can be determined in one or two operations. In case if the surroundings and the other things are complicated, then the solution for such complex problem cannot be determined so easily in one or two operations. Hence, an alternative method called finite element analysis or finite element methods can be adopted, in which the whole body or system is being divided into a many small elements whose characteristics are studied, and then it is rebuilt into the original system from such smaller elements in order to understand the behavior of the entire system. Finite element methods. The finite element methods, it is sometimes referred as finite element analysis. It is a numerical method used to obtain approximate solutions of boundary value problems in engineering. In this method, given problem or a domain is being converted or divided into a smaller regions which are called as elements. These elements are interconnected at specific joints which are called as nodes. These are the points where the properties are to be determined for an element. Since the actual variation of the field variables such as displacement or temperature or heat flux or any fluid velocity are not known inside the domain, it is assumed that the variation of the field variables within each element can be approximated by a simple function. These approximating functions are designed in terms of a field variables of the nodes. Thus, in finite element methods, unknowns are the field variables of the nodal points. Once these are found, the field variable at any point can be found by using the interpolation functions. After finding the element properties, the next step in finite element methods is to find the global properties. These global properties are expressed in terms of equilibrium conditions. The equilibrium conditions are being specified as K into Q is equal to F, where K is global stiffness matrix and Q is nodal displacement vector and F is nodal force vector. Then, by applying a boundary conditions and solving using a suitable method, equations results into a set of simultaneous equations. The solution of the simultaneous equations are values of nodal unknowns. Thereby, we can calculate other required values such as stress, strain, etc., depending on the type of the physical problem being analyzed. Now, let's see the advantages and disadvantages of finite element methods. The first advantage is a model irregular shaped bodies quite easily. Finite element methods allow us for the subdivision of complex geometries into smaller, more manageable elements, making it possible to model irregular shapes accurately. This is particularly useful in engineering and design when dealing with real world structures that might not have simple or irregular geometries. Finite element methods it can handle general load conditions without difficulty. It means finite element methods can handle a wide range of load conditions. It includes static, dynamic, thermal, and other types of loads. This flexibility makes it suitable for analyzing structures and other systems under various operating conditions. The next advantage it can model bodies composed of several different materials. Finite element methods can accommodate material heterogeneity by allowing different materials to be assigned to individual elements. This is crucial for simulating structures made up of a composite materials or assembly with different components. The next advantage is it can handle unlimited numbers and kinds of boundary conditions. Finite element methods is highly adaptable. When it comes to imposing boundary conditions, it can handle a wide variety of constraints such as fixed displacements, distributed loads, temperature gradients, and much more. This versatility is essential in accurately simulating real world scenarios. The next advantage is it can vary the size of elements. Finite element methods it allows for the adjustment of element size to achieve the desired level of accuracy. By refining the mesh in critical areas and using a larger elements in less critical regions, engineers can control the balance between a computational efficiency and solution accuracy. The next advantage is it can alter the finite element model relatively easily and cheaply. That is, finite element methods offers the advantage of easy model modification. Engineers can update the model by changing material properties, geometry, boundary conditions, or loadings without having to start from scratch. This flexibility reduces the cost and time required to make design changes and iterate on designs. And the next advantage is that it includes dynamic effects. Finite element methods is capable of analyzing dynamic behavior such as vibrations, oscillations, and transient phenomena. This makes it a valuable tool for assessing the response of a structures and systems to dynamic loads, which is essential in various fields, including mechanical and civil engineering. Let's discuss about the disadvantages of finite element methods. The first disadvantage is that it is a time consuming process. Finite element methods can be computationally demanding, particularly when dealing with the large and complex models. The process of dividing the domain into elements, setting up equations, and solving them can be time consuming. The time required for analysis increases as the number of elements and the degrees of freedom in the model increases. The second disadvantage is that in order to analyze a large number of smaller elements, due to human fatigue, we have to depend on computer packages. Finite element method analysis often involves dividing the problem domain into a larger number of smaller elements, which can be tedious and error prone when done manually. To handle the complexity and the volume of calculations required for practical engineering problems, engineers they need to rely on specialized computer software packages which can be expensive and require expertise to use efficiently and effectively. The next disadvantage is that results obtained are closer to the exact solutions only if the system is divided into a large number of smaller elements, which means finite element methods provides approximate solution and its accuracy depends on mesh density. To obtain a more accurate results, the model need to be divided into a larger number of smaller elements, which can lead to increased computational demands. Finding the right balance between a computational cost as well as the solution accuracy is really a challenging in finite element analysis. The last disadvantage is that it cannot produce exact solutions. Finite element methods is a numerical approximation technique, and as such, it cannot provide exact analytical solutions for most of the engineering problems. The accuracy of finite element methods results depends on factors such as element shape, size, and convergence criteria. While finite element methods can provide highly accurate solutions when appropriately applied, it remains as approximation method and may not always match exact analytical solutions. Thank you.